Welcome to part 2 of Powell Buck's Marine Construction Series. In this video, we're going to cover the different types of jetties, the materials used, design consideration, the construction process, and how to ensure longevity. Before we begin, we want to thank our sponsor and good friends at Jet Filter Systems. If you want to prevent retaining and seawall failure, well, how about saving money on repairs? Check out jetfiltersystem.com to learn more about their super efficient weep hold filters. Now back to the video. What is a jetty? A jetty is a structure that extends from the shore into the water and is typically constructed to protect a channel or harbor entrance from silting and erosion. Jetties can be made from a variety of material, including rock, concrete, steel, or even a combination of material. The design of a jetty will depend on the specific location, the forces of waves and currents, and the intended application of the jetty. Let's take a look at the different types of jetties. The different types of jetties. There are several different types of jetty designs available, each with their own specific uses and benefits, including groin jetties. Groin jetties are short jetties that extend perpendicular to the shore and are typically used to reduce erosion and protect beaches. Finger jetties, often used at marinas, finger jetties extend from the shore and are used to create a protected area for boats and ships. T-head jetties. T-head jetties extend from the shore and then turn at a right angle, forming a T-shape. Because of that unique shape, T-head jetties are often used at ports and harbors to provide berthing and docking space for boats and ships. Training jetties. Training jetties are longer jetties that are intended to guide and control the flow of water in a channel or harbor entrance. Combination of jetties. Multiple jetties can be connected together in order to protect larger areas of shoreline from erosion and to provide multiple berthing and docking spaces for boats and ships. Materials used for jetty construction. The most common materials used for jetty construction include rock, natural rock, like granite or limestone. It's a durable and long-lasting material that can be used for larger jetty projects as well as breakwaters. Steel, suitable for larger projects such as ports or harbors. Steel is durable and responds well to corrosive environments. Concrete. Concrete's a versatile, durable material that's ideal for smaller jetty projects, as well as repairing and maintaining existing jetties. Timber. Timber's a traditional material used for jetty construction that's inexpensive and easy to work with. That being said, timber is typically not a suitable option for areas with strong waves or corrosive environments. Design consideration for jetties. Each jetty design offers its own set of advantages and disadvantages. For this reason, it's imperative to consider the specific design of a jetty before any construction takes place. The most crucial design considerations include cost and budget. Obviously, the cost and budget for the jetty will determine many of the design factors. Site assessment. Engineers will need to assess the specific location where the jetty will be constructed, taking into account factors such as the water depth, the wave and current conditions, as well as the geology of the area. Access and usability. Engineers will need to consider the access and usability of the jetty, particularly to ensure that it's accessible to the various types of vessels. Load calculations. Engineers must calculate the loads that the jetty will be subjected to, including the forces of waves and currents, as well as the potential mass of the vessels that will be using the jetty. Environmental impact. Engineers will need to consider the environmental impact of the jetty in order to minimize any negative effects on the coastal ecosystem. Construction methods. Engineers will need to consider the construction method and material that will be used to construct the jetty, taking into account factors such as ease of construction, durability, and resistance to the forces of waves and currents. Maintenance and repair. Engineers will need to consider the anticipated maintenance and repair requirements of the jetty. Again, these are just what we feel are the most crucial design considerations. Other design considerations may exist, so be sure and do your due diligence.
Now, before we continue, be sure to crush the like button and subscribe to receive more marine construction guides. We appreciate your support.
Jetty construction process. Jetties are generally constructed with the following procedure. Number 1. Site selection and survey. The location for the jetty is chosen and surveyed in order to gather necessary information, including soil conditions, tide levels, and wave patterns throughout the area. Number 2. Design and planning. Engineers and architects design the jetty based on the site survey as well as the intended application of the jetty. Number 3. Permitting. To ensure that the jetty complies with all local and national regulations, the construction project must go through various permitting processes, including environmental impact assessments. Fourth, excavation and dredging. In order to create a stable foundation for the jetty, the seafloor is excavated and dredged. Number 5. Piling and foundation work. Continuing the creation of a strong foundation, piles are driven into the seabed. 6. Decking and substructure. The deck of the jetty is constructed, as well as any additional structures, including walkways and railings. And 7. Accessories. Any necessary accessories are applied. That includes lighting and signs. Keep in mind, this is a general process for constructing a jetty. Of course, the construction process will vary by project. Maintaining, repairing, and ensuring the longevity of jetties. Considering that jetties are exposed to extreme forces of nature like waves, currents, storms, and erosion, proper maintenance of jetties is essential. These environmental factors pose serious risks for safety, as jetties can lose their structural integrity and be less effective in protecting the coast. Here are some of the best practices to ensure the longevity of jetties. Monitoring. Monitoring the jetty's condition, including measuring the water level and wave patterns, can help identify any potential issues that may need to be addressed. Regular inspections. Regular inspections are crucial to identify any potential issues, such as cracks, erosion, or damage caused by boats. A lack of regular inspections can lead to more serious, costly issues. Regular cleaning. Regular cleaning of the jetty, including removing debris and sediment, can prevent buildup and erosion that cause damage to the jetty over a period of time. Regular maintenance. Regular maintenance such as repainting, replacing worn or damaged material, and restoring the jetty's structural integrity can help extend both the life and aesthetics of the jetty.
Once again, we want to thank our sponsor, Jet Filter System. Check them out at jetfiltersystem.com or call 800-475-2029 to save money and prevent retaining and seawall fade. Well, that's all we have for now, and be sure and subscribe so you'll be notified whenever we release a new video guide.
Hello everybody and welcome back to the iMachines TV channel. Driven steel tube piling is a vital aspect of constructing solid and stable foundations for various structures, including LNG process plants. In the context of an LNG plant in northern Australia, the use of large-diameter steel tube piles up to 12.5 meters in length is crucial for ensuring the structural integrity and long-term stability of the facility. The process of driven steel tube piling involves using powerful hydraulic hammers to forcefully insert the steel tubes into the ground. The hydraulic hammers deliver high-impact blows to the top of the pile, transmitting energy down the pile shaft and into the ground, displacing soil and creating a path for the pile to penetrate deeper. The repetitive driving action causes the steel tube piles to be driven into the ground, forming a robust foundation capable of supporting the weight and load of the LNG process plant. The choice of steel tube piles for this particular LNG plant project is significant due to their inherent strength and durability. Steel is renowned for its high tensile strength, making it an ideal material for piling applications that require the support of heavy structures such as LNG plants. Additionally, steel tube piles offer excellent resistance to corrosion, ensuring the longevity of the foundation in the harsh environment often found in northern Australia. The large diameter of the steel tube piles further enhances their load-bearing capacity. The greater surface area of the pile allows for the distribution of the structure's weight over a larger area, reducing the risk of settlement and ensuring a more stable foundation. Driven steel tube piling is a proven and efficient method for constructing strong foundations for LNG process plants. Its ability to provide stability, withstand heavy loads, and resist corrosion makes it an excellent choice for projects in demanding environments like northern Australia. The construction process of the QCLNG jetty involves several key steps. The jetty is approximately 250 meters long, extending from the onshore abutment to the front of the jetty head. It features 3 luring dolphins on each side and 2 breast dolphins. The construction work is carried out using a traveler arrangement and marine spreads. The traveler is a standalone equipment that serves as a working platform during the transition between land and offshore operations. Once the trestle reaches the jetty head, it is reconfigured to install modules on the second half of the Ben's quay. Safety is a major concern, including work over water and at heights, requiring specialized equipment and coordination among various contractors and subcontractors. The breakwater construction at Port City Colombo is a significant project aimed at ensuring the safety and stability of the reclaimed land and the surrounding area. The breakwater serves as a protective barrier, shielding the port and the newly formed beach from the impact of extreme storm conditions. The construction process involves careful planning and engineering expertise. The breakwater is typically constructed using large concrete blocks or rock formations strategically placed along the coastline. These structures help reduce the energy of incoming waves, thereby creating a calmer sea condition within the protected area. The construction of the breakwater at Port City Colombo involves extensive surveying, geotechnical studies, and design work to ensure its effectiveness. It also requires the use of specialized machinery and equipment to transport and position the heavy materials. The construction team follows a meticulous timeline and adheres to stringent safety protocols to ensure the project's success. They work closely with engineers, marine experts, and environmental consultants to minimize any potential impact on the surrounding ecosystem. Once completed, the breakwater will provide a secure harbor for ships and vessels, allowing for efficient and safe maritime operations. It will also create a tranquil beachfront, enhancing the recreational and tourism potential of Port City Colombo. TJS Marine, known as the Jetty Specialist, is responsible for the design and construction of the Clump Point Boating Infrastructure Project. This project entails the creation of a concrete jetty, aluminum pontoons, and a concrete floating walkway. The construction of the Clump Point Jetty involves careful planning and expertise in marine engineering. TJS Marine's team of specialists has extensive experience in designing and building jetties that can withstand the challenges of the marine environment. The concrete jetty serves as a sturdy and reliable platform for boating activities. It provides a safe and accessible area for boats to dock, ensuring ease of embarkation and disembarkation for boaters and passengers alike. The aluminum pontoons are designed to provide stability and buoyancy for boats, enabling them to remain afloat even in turbulent waters. These pontoons are lightweight yet robust, offering durability and resistance to corrosion. ICOP SPA is an Italian company specializing in offshore piling services based in Trieste. With a reputation for excellence and expertise, ICOP has established itself as a leading player in the offshore construction industry. The company offers a wide range of piling solutions for various offshore structures, including oil and gas platforms, wind farms, and marine infrastructure projects. ICOP's piling services involve the installation of foundation piles using advanced techniques and equipment. The company employs highly skilled engineers, technicians, and operators who ensure the precise and efficient execution of piling operations. They leverage state-of-the-art technology and adhere to stringent safety and environmental standards to deliver reliable and sustainable solutions. Trieste, strategically located on the Adriatic Sea, provides ICOP with a geographically advantageous position for offshore projects in the Mediterranean region. The company's local presence and extensive experience enable them to effectively manage the unique challenges posed by offshore environments, such as harsh weather conditions and complex geotechnical conditions. In June 2012, Sheet Piling UK Limited was invited to tender for the construction of two circular cofferdams at the outer harbour breakwaters forming the entrance to Great Yarmouth Harbour. The project had strict conditions requiring the cofferdam installation to be completed by the end of August 2012, with minimal disruption to normal harbour activities and ship movements. Sheet Piling UK Limited chose a construction method that involved pre-assembling the sheet pile cofferdams on adjacent quay sites before lifting, floating, and positioning the fabricated works using a large sheer leg crane barge. To begin the construction process, a robust temporary work support frame was fabricated and assembled on the quayside. The interlocking sheet piles with straight web profiles were carefully placed around the frame and secured at the upper level. Pile creep was closely monitored to ensure the circle was closed without inducing closure strain. A jacket piling barge was mobilized and positioned at the proposed installation location. A Smith Tuck Lift 7 sheer leg barge was brought in for heavy-duty lifting, and straps were connected to lifting points on the temporary works assembly. The fabricated cofferdam, weighing approximately 400 tons, was then lifted from the quayside and precisely floated into position using GPS positioning techniques. Once accurately lowered onto the seabed, 860 mm diameter tubular piles were vibrated to a depth of 5 meters to firmly anchor the structure in place. The straight web sheet piles were sequentially driven to the design level using a crane-suspended vibratory hammer. Hydraulic pumps were used to place fill materials from a land-based stockpile, effectively filling the cells of the cofferdam. This innovative construction method allowed both cofferdams to be accurately installed at the harbor entrance within a 1-week period, without causing any disruption to normal harbor operations. It is believed that this was the first time such a method of constructing cellular sheet pile cofferdams had been used in the tidal waters of the UK. The entire subcontract works were completed by the end of August 2012, meeting the contract deadline. The circular cofferdams provided the necessary structural support for the outer harbor breakwaters, allowing for continued safe navigation into Great Yarmouth Harbor. The construction process demonstrated the use of advanced techniques and careful planning to minimize disruption and ensure the successful completion of the project within the specified timeframe. The standby jetty construction project at the Port of the Age in the Gulf of Cambay, located on the west coast of India, is a significant endeavor. This port serves as a crucial terminal for the offloading of liquefied natural gas, LNG, and plays a vital role in India's energy infrastructure. Petronet LNG awarded the project to Afcons, which aims to construct a standby jetty for Petronet LNG. The construction of this jetty presents several major challenges. The area experiences rough sea conditions with high tidal variations and strong currents. The location of the jetty is in a deep sea region where the tidal variation can reach up to 10 meters, making it one of the most severe in the international scenario. However, Afcons, with its rich experience in working on challenging offshore projects in India and overseas, was confident in completing the project ahead of schedule. Designed on international standards and codes for safe operation and serviceability, the jetty is intended to facilitate the berthing and offloading of LNG vessels in all seasons. The new jetty, running parallel to an existing one, will increase the storage capacity of Petronet LNG for LNG. It extends 2.5 kilometers into the sea and features a jetty head structure consisting of breasting dolphins and mooring dolphins to secure the ships during the offloading process. Various catwalks connect different parts of the jetty head structure. The standout feature of the jetty is its ability to receive large LNG carriers of up to 266,000 cubic meters and offload the product to storage tanks within 24 hours. It is the largest jetty in India capable of accommodating ships of this size and capacity. To construct the jetty in an area with a high tide of up to 10 meters, Afcons deployed their largest self-elevating platform called Samrat. This massive jack-up platform, weighing 2,928 tons, is designed to work in depths of more than 30 meters. Additionally, Afcons utilized smaller jack-up platforms like Maharaja and Maharani for specific tasks. The construction process involved various stages, including the erection of piles, procurement and joining of steel pipes, and placement of prefabricated concrete decking. Modern machinery and efficient processes were employed to ensure speedy, safe, and high-quality execution of the project.
Trenching in soil and rock. Placing of armor 1 ton to 3.75 tons with crane barge. Placing of acropods with crane barge. Placing of tow armor 4 ton to 8 ton with crane barge. Unloading of core 1 kg to 1000 kg happens at Chara Anchorage loading point. That is 3 nautical miles away from breakwater location, from 50,000 deadweight tonnage ship or vessel onto hopper barge or flat top barge with the help of self-geared cranes on ship or vessel. Filling of core with hopper barge below.